Let us solve another problem. If a person is walking up a hill at an angle of 30 degrees and at a speed of 3 kilometers per hour, how much altitude will he reach in 3 hours? So let's draw a picture. So a person is walking up the hill at an angle of 30 degrees, right? So let's draw this, and this will be a right angle triangle. So he's walking up the hill at 3 kilometers per hour. So this is the altitude h. So the question asks you how much altitude would he reach after 3 hours. So let's first calculate the distance he walked in 3 hours. So the person walks 3 kilometers in 1 hour. So in 3 hours he walks how much? So x is nothing but 3 times 3, which is 9 kilometers. So we know now that this distance, let's name this triangle A, B, C. We now know that AC is 9 kilometers, and we are asked to calculate BC, which is H, and the angle we know is 30 degrees. So theta is equal to 30 degrees. So if you remember our mantra in trigonometry, Soka Toa, you can observe that in our problem we have an opposite side and we know the hypotenuse. So opposite side and hypotenuse, the function we have to apply is sine. So sine 30 is equal to h by 9, opposite side by hypotenuse. So h is nothing but 9 times sine 30 degrees, and from our values that we have seen in the previous lesson, sine 30 is nothing but 1 by 2, which is equal to 4.5 kilometers. So if a person is traveling at a speed of 3 kilometers per hour up the hill, after 3 hours he would have traversed a distance of 9 kilometers and have reached a height of 4.5 kilometers. Let us look at another problem. If you are looking at a bird which is on the top of a 40 feet tree at an angle of 60 degrees, what is the distance between you and the tree? So let's draw it. So let's first draw a tree. And you are looking at a bird which is on the top of the tree. So the height of the tree is 40 feet. Let's call this A and B. You are looking at the bird at an angle of 60 degrees. Okay, so the problem asks you to calculate the distance d between you and the tree. So we know from our mantra Soka Toa that opposite by adjacent is tan. So applying that to theta, which is here 60, so tan 60 is equal to opposite by adjacent. Opposite is AB by adjacent is AC, which is equal to 40 by D. And we know from our table from the previous lessons that tan 60 is root 3. So root 3 is equal to 40 divided by D. So D is nothing but 40 by root 3 feet. The distance between you and the tree is 40 by root 3, and you can further simplify that. Yeah, 40 by 1.732, which is roughly equal to 23.09 feet. Let us look at another example. An inclined plane is resting on the top of a barrel. The distance between the barrel and the end of the inclined plane, which is on the ground, is 8 feet. What is the length of the inclined plane if the angle of inclination between the ground and the inclined plane is 45 degrees? So let's first try to use the information given in the problem and draw our triangle. So there is a barrel. Right? And there is an inclined plane which is resting on the top of the barrel. And the other end of the inclined plane is on the ground. So the distance between the end of the ground and the barrel is given as 8 feet. And we are also given the angle of inclination between the inclined plane and the ground is 45 degrees. So we know that. Then we can. Okay. So now that we know that this is a right angle triangle, and we know the distance between the end of the inclined plane and the barrel is 8 feet. Let's name the angle ABC. We are asked to calculate the length of the inclined plane. So we are being asked to calculate the length of the inclined plane, which is we are asked to calculate this. So from the right angle triangle, we know that this side AC is the hypotenuse, and we know the distance between the ground, which is distance between the end of the inclined plane that is on the ground and the barrel is 8 feet. From our mantra again, so ka toa. Let's see what trigonometric function we can apply. So we have an angle 45. We know the adjacent side, and we know the we are asked to calculate the hypotenuse. So adjacent and hypotenuse is cos, right? So apply the formula. Cos 45 degrees equal to adjacent by hypotenuse, which is 8 by L cos 45. Right? So L equal to 8 times cos 45. And from our table we know that cos 45 is 1 by root 2, which is nothing but, to simplify this, it is 4 times 2 is 8 times 1 by root 2. So root 2 get cancelled, 2 get cancelled as root 2, so it will be 4 root 2. So the answer is 4 times 1.414. So it is close to 5.6 feet. So the length of the inclined plane is 5.656 feet. Now let us try to work out a little harder problem. The problem states that A balloon is hovering about 600 feet above a lake. Okay, so let's draw that. So there is a balloon, there is a lake, and the height is 600 feet. Let's name it AB. A person in a boat looks at the balloon at an angle of 60 degrees. Okay, so assuming that there is a person here in this boat is looking at the balloon at an angle of 60 degrees. Okay, after traveling for 40 seconds, he now sees the balloon at an angle of 30 degrees. So he did some traveling, and now he is actually seeing the balloon at a 30-degree angle. Okay, so he's here right now, and it took 40 seconds for him to travel this distance. Okay, how fast is he traveling? So what we need to find out is the speed at which he is traveling. So in order to calculate the speed, so we need to find the distance. So let's call this c, and we'll call this d. So if we calculate the distance cd and divide it by the time, we will get the speed. So the goal of this problem is to find the distance cd. So now let's look at the triangle ABC, the first right angle triangle. Right? So we have again our mantra, Soka Toa. So let's calculate this distance. Let's call this x. So we need to, let's calculate the distance x, which is BC. So we have the opposite side and we need to calculate the adjacent side. So from our formula TOA, which is tan, we can calculate this. So let's first do that. So tan 60 is equal to AB by BC, which is 600 by x. So x is nothing but 600 divided by tan 60, which is 600 by root 3, which is nothing but 200 root 3. So we have calculated x to be 200 root 3. So we also know that after 40 seconds he is looking at angle at 30 degrees. So let's calculate this distance y, which is BD. So in order to calculate that, again we have the opposite side and we need to calculate the adjacent side. So tan 30 is equal to opposite side, which is AB, by adjacent side, which is BD, which is nothing but 600 by y. So y is 600 by tan 30, which is 600 by 1 by root 3, which is 600 root 3. So now we know distance y is 600 root 3. What we need to calculate is CD. We know that BD is equal to BC plus CD. So that is BD, which is y, equal to BC, which is x, plus CD. So CD is y minus x. And we know from here y is 600 root 3, x is 200 root 3. So this is 400 root 3. So basically the person in the boat traveled a distance of 400 root 3 in 40 seconds. So the speed formula is distance by time. The distance he has traveled is 400 root 3 in 40 seconds. So that means it is 10 root 3 feet per second, which is nothing but 17.32 feet per second. So we have calculated the speed of the person by applying trigonometry to two different triangles and using the tan function. Let us work on another interesting problem. So the problem states as follows. There are two runners who are participating in a 400-meter running race. The first runner runs on the correct path and finishes the race. The second runner, however, starts at a deviation of 45 degrees and finishes the race. So when they both finish the race, how far are they from each other is the first question. And how much more distance did the second runner ran is the second question. So let's put this data into a right angle triangle. So there are two runners who are running a 400-meter running race. It starts at A and ends at B. The first runner ran the correct path and finished the race. The second runner ran at an angle of 45 degrees from his initial position and completed the race. So if you look at this diagram now, the second runner would be at C and the first runner would be at B when they both finish the race. So the first problem asks you to calculate the distance between the two runners, in which case here is BC. So what is this? So again, let's write our mantra. So ka toa. So we have an angle of 45 degrees. We have to calculate the opposite side and we know the adjacent side. So that is again tan. So that means tan 45 is equal to opposite by adjacent, which in this case is x by 400. So we know tan 45 is 1. So tan 45 x by 400, which is nothing but x equal to 400 meters. So when they finish the race, distance between the two runners is 400 meters. The second question asks us to calculate how much more distance did the second runner ran. So the distance ran by the second runner is given by the hypotenuse AC. So we can apply any sine formula over here, either sine or cos, because we are asked to calculate y. We have both the opposite as well as the adjacent side. Or if you don't want to apply the formulas, you can apply the Pythagoras theorem and say hypotenuse square is equal to the sum of the squares of the both the sides and calculate it that way as well. But I'll apply a trigonometric ratio and to solve this problem. So I'll apply the sine. So when I'm applying the sine, I know from the mantra it's opposite side by hypotenuse. So sine 45 is opposite side, which is 400 meters, divided by hypotenuse, which is y. So in our case, so y is 400 by sine 45. We know that sine 45 is 1 by root 2. So y is 400 by 1 by root 2, which is nothing but 400 root 2. So how much more distance did he travel? So in order to calculate that, we subtract the distance traveled by the first runner from the distance traveled by the second runner. We know from our diagram that the first runner ran the distance of 400 meters and the second runner ran the distance of 400 root 2 meters. So the delta is 400 root 2 minus 400, which is root 2 meters. So the second runner had to travel root 2 or 1.414 meters more than the first runner to complete the race. Now let us solve another problem. The problem states that a bird is sitting on the top of a 20 feet tree and is watching two houses on either side of the tree at an angles of depression of 30 degrees and 60 degrees respectively. What is the distance between the two houses? So let's draw the diagram. So let's assume this is a tree and there is a bird sitting on the top of the tree and is watching two houses on either side of the tree at angles of depression. So angles of depression are represented as follows. So let's connect that. So 30 degrees is the angle of depression. This angle of depression is represented like this way. So this is the angle of depression and the other one is the 60 degrees. So we know that this is 90 degrees and from this picture you can depict that this is 90 as well. So this is 30, so this becomes 60. Same thing, this is 90, so this is 30 degrees. The height of the tree we know is 20 feet. Let's call this A, B, C, and D. We know that AC, which is the height of the tree, is 20 feet. We know that angle BAC is 60 and angle CAD is 30 degrees. So our problem asks us to calculate the distance between the two houses. We can call BC as X and CD as Y. So we need to calculate, BC is X, CD is Y. We need X plus Y is how much? Which is BD. So let's apply the trigonometric function for the first triangle ABC. So our mantra, which is so sa to we know that we have the adjacent side which is 20 feet and we need to calculate the opposite side which is X. So opposite and adjacent is tan. From triangle ABC, tan 60 is equal to opposite X by adjacent which is 20. So X is 20 times tan 60 which is 20 root 3. Okay, as we know tan 60 is root 3. Similarly, from triangle ACD, we know that we apply the same formula again. We have to calculate the opposite side and we have the adjacent side which is 20. So the angle is different though. Tan 30 is equal to opposite which is y by adjacent which is 20. So that becomes y is equal to 20 tan 30 which is nothing but tan 30 is root 3. So 1 by root 3. So y is 20 by root 3. So the problem asks us to calculate BD which is x plus y which is 20 root 3 plus 20 by root 3 which is equal to 20 root 3 times root 3 is 60. 60 so 20 root 3 times root 3 plus 20 divided by root 3, which is equal to 80 by root 3. So the solution for this problem is the distance between the two houses is 80 by root 3 feet.